Hi everyone, welcome back to my geometry tutorials. Today I want to go over quadrilaterals some more. So let's start off with some definitions. So a rhombus is a parallelogram with at least two congruent adjacent sides. So the main thing to remember about rhombuses is they look like diamonds a lot of times. So this is a typical rhombus ABCD. A trapezoid is a quadrilateral in which one pair of opposite sides are parallel. So the main thing to know about trapezoids is that they only have one pair of sides that are parallel. That's unlike the parallelogram, which has both pairs of opposite sides which are parallel. So if we look at this one, ABCD, segment AB is parallel to segment CD, but segment AC is not parallel to segment BD. The last definition: a square is a rectangle with at least two congruent adjacent sides. So just remember for right now that rectangles and squares are both types of parallelograms. And here's a Venn diagram kind of showing the relationship between these different kinds of quadrilaterals. So the large oval represents all quadrilaterals. This oval here represents all parallelograms, and this oval here represents all trapezoids. So you can see immediately that all parallelograms are this the oval containing the parallelograms is entirely inside the oval containing quadrilaterals. So all parallelograms are quadrilaterals. And in the same way, the oval containing trapezoids is entirely inside the oval containing quadrilaterals. So all trapezoids are quadrilaterals. But you can see that the oval containing parallelograms and trapezoids don't intersect. So no parallelograms are trapezoids and no trapezoids are parallelograms. So I made up this kind of quick true and false test to help you think critically about the relationship between these different shapes. So the first question is, all squares are rhombuses, and that's true. The region containing squares is entirely inside the rhombus oval. So here's the region containing squares, point 1, right? And this region's entirely inside this oval containing rhombuses. So all squares are going to be rhombuses. Statement 2, all trapezoids are parallelograms. I went over this in my last slide, and the answer is false, right? Because the trapezoid oval does not intersect the parallelogram oval. So if you take point 2, you can move it around anywhere inside this trapezoid oval, and it'll never be inside the parallelogram oval. All rhombuses are parallelograms. That's true. The rhombus oval is entirely inside the parallelogram oval. Look at point 3. So the rhombus oval is here, and it's entirely inside the parallelogram oval. So all rhombuses are going to be parallelograms. All parallelograms are rhombuses. This is false. The parallelogram oval includes areas outside the rhombus oval. Look at point 4. So if you take point 4, it's inside the parallelogram oval, but it's not inside the rhombus oval. So that shows that not all parallelograms are rhombuses. The statement, some rectangles are not rhombuses, and that's true. The rectangle has parts outside of the rhombus oval. So if you look at point 5, this is a rectangle that's not a rhombus, right? So some rectangles are not rhombuses, but some rectangles are rhombuses. So for example, a square is a type of rectangle that is a rhombus. So the last one, some quadrilaterals are neither parallelograms nor trapezoids, and the answer to that statement is true. Here's an example of a quadrilateral that's neither a parallelogram nor a trapezoid. So if I picked, some region here, well, that would not be inside the parallelogram oval, and it would not be inside the trapezoid oval. So, that's why there are some quadrilaterals that are not parallelograms and not trapezoids. Okay, I want to derive some properties about rhombuses. So we're given that segment AB is congruent to segment AC and that ABCD is a parallelogram. So remember, all rhombuses are parallelograms, right? And the definition of a rhombus is, has two congruent adjacent sides, right? So let's write down what we know. We know that segment AB is congruent to segment AC. That's a given. And that ABCD is a parallelogram, which is a given. So we know since ABCD is a parallelogram, the opposite sides are going to be congruent, right? Because that's a property of parallelograms that we went over in my last video. So we know that segment AB is going to be congruent to segment CD. In the same way, segment AC is opposite segment BD, so they're going to be congruent. AC segment is congruent to segment BD for the same reason. Now I'm going to look at statement 1, 3, and 4. So segment AB is congruent to segment AC. And we have segment AB is congruent to segment CD, and segment AC is congruent to segment BD. So we know from 1 that these two parts are going to be congruent. So we know that segment BD is going to be congruent to segment CD. Segments that are congruent to congruent segments are congruent. And if we look at statement 3 and statement 5, so we see that segment AB and segment BD are both congruent to segment CD. We know that segments that are congruent to the same segment are congruent. So in other words, segment AB is congruent to segment BD. So we know segment AB is congruent to segment AC. We know that segment AB is congruent to segment CD. And we know that segment AB is congruent to segment BD. So in other words, all the sides of the rhombus are going to be congruent. Okay, so we're given ABCD is a rhombus, and I want to prove that line BC is perpendicular to segment AD. So we write down what we know. We know that ABCD is a rhombus, right? And we know that all sides of a rhombus are congruent, right? We just proved that in our last slide. So segment BA is going to be congruent to segment BD, and segment CA is going to be congruent to segment CD because all sides of a rhombus are congruent. So we know if 2 points are equidistant from the endpoints of a segment, then those points determine the perpendicular bisector of that segment. So we know that side BA is congruent to side BD, and we know that side CA is congruent to side CD. So in other words, point B and C determine this perpendicular bisector for segment AD. So we know that a perpendicular bisector of a segment is perpendicular to that segment. So we know that line BC is going to be perpendicular to segment AD. So the main thing I want you to get out of this is that the diagonals of a rhombus are perpendicular. Remember, a diagonal is a segment that joins two non-adjacent vertices of a quadrilateral. So yeah. So let's go over one more property about rhombuses. So we're given that ABCD is a rhombus, and I want to prove that angle 1 is congruent to angle 2, and angle 3 is congruent to angle 4. Write down what I know. I know that ABCD is a rhombus, And we know that all sides of a rhombus are congruent. So segment AB is congruent to segment BD. We know the diagonals of a rhombus are perpendicular, so segment BC is going to be perpendicular to segment AD. So since perpendicular segments meet at right angles, we know that angle BOA and angle BOD are right angles. And we know a triangle with a right angle is a right triangle, so triangle AOB and triangle DOB are right triangles. So remember, hypotenuse is going to be the side that is opposite the right triangle, the right angle inside a right triangle. So segment AB is going to be the hypotenuse for triangle AOB, and segment BD is going to be the hypotenuse for right triangle DOB. I'm going to use the reflexive property of congruence, so segment OB is congruent to itself, and I can use the hypotenuse leg postulate and conclude that triangle AOB and triangle DOB are congruent triangles. And we know that corresponding parts of congruent triangles are congruent. So we know that angle 1 is going to be congruent to angle 2. So we proved this first fact right here. So going back to segment BC is perpendicular to segment AD, we know that angle BOD and angle DOC are right angles, right? Because perpendicular segments meet at right angles. And we know that segment BD is going to be congruent to segment CD because all sides of a rhombus are congruent. So we know, since we have this right angle here, that on both sides here, that triangle BOD and triangle DOC are right triangles, right? Triangle with a right angle is a right triangle. So then I can use the reflexive property of congruence again. Segment OD is congruent to itself, and then I can apply the hypotenuse leg postulate to conclude that triangle DBO is going to be congruent to triangle DCO. In other words, angle 3 is going to be congruent to angle 4, using the fact that corresponding parts of congruent triangles are congruent. So the big takeaway of this is that rhombus diagonals bisect the vertex angles. So I know we didn't show it for vertex A and vertex C, but you can just use the same kind of reasoning here and derive this. So you have this diagonal here, so what this all means is it's going to split this angle into two, right? Angle B into two congruent parts, angle C into two congruent parts, and this diagonal AD is going to split angle D into two congruent angles, and angle A into two congruent angles. Okay, so the last two slides are actually pretty easy. So we're given that ABCD is a square, and I want to prove that all sides of the square are going to be congruent. So I'm going to write down the facts that I know. ABCD is a square, and we're given that information. So remember, if we look back at the Venn diagram, we know that all squares are going to be rhombuses, right? They're all contained in this rhombus oval. But we proved earlier that all sides of a rhombus are congruent. So in other words, all sides of the square are going to be congruent. So that's the property of squares. All the sides are going to be congruent. Okay, so we're given that ABCD is a square, and I want to prove that triangle ABC is isosceles. So, this segment BC is going to be a diagonal, right? Because it joins these two non-adjacent vertices of this quadrilateral, right? So I just showed that all sides of a square are congruent. So in other words, segment AB is going to be congruent to segment AC, right? Well, if you look at this triangle ABC, if a triangle has at least two congruent sides, it's an isosceles triangle, right? So in other words, triangle ABC is isosceles. So that pretty much finishes up what I have for you today. I enjoyed doing this lesson. I enjoy working with these different shapes and all that. I think that that's one of the more interesting parts of geometry. So definitely go over this video and go over it a few times to kind of make sure that you understand what's going on. In my next video, I'm going to go over trapezoids, so I'm going to have a video just for that. And then in the video after the next one, we're actually going to do some problem solving with these different kinds of shapes. So I hope you enjoyed this video, and I hope to see you during my next video. All right, take care. Have a good night.